Hello everyone, welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining us here today as we wrap up our discussion of operations with rational numbers. Today we're talking about division of rational numbers, specifically division of rational numbers that are in fraction form. The nice thing is we've really laid a lot of groundwork for today's lesson, so this one should be a little shorter than most of them. Let's go ahead and hop right in and see what we can learn. I am going to take you down a little trip down memory lane for just a bit. I'm going to give you three quick examples that are going to remind us of a rule that's going to be very helpful for us as we are dividing our rational numbers. So I want you to think about 18 divided by 2 because I know you know 18 divided by 2 is 9. But I want to show you a different problem. 18 times 1/2. Now, many of you can probably do that with mental math, but I'm going to do it out the long way, just so you can see how this works. It gives us a nice review of a whole number being multiplied by a fraction. You'll remember that 18 is the same as 18 over 1, and we learned in our multiplication of fractions or rational numbers lesson last time that when we multiply fractions, we multiply the numerators together, 18 times 1, and we multiply the denominators together, 1 times 2, giving me a numerator of 18 and a denominator of 2. And of course, 18 divided by 2 is 9. Now, the first thing you're probably thinking is, hey, wait just a second. Notice that 18 divided by 2 has a solution of 9. And 18 times 1/2 also has a solution of 9. There is a reason for that. Notice up here we are dividing by 2, and over here we are multiplying by 1/2. 2 and 1/2 have a special relationship. They are reciprocals of one another. Reciprocals. Notice when you have reciprocals like 2 times 1/2 and you multiply those reciprocals together, you get a numerator and a denominator that are the same, which results in a 1. So since 2 times 1/2 results in a 1, they are reciprocals. And whenever I have a division problem, I can predict ahead of time what multiplication problem will give me the same solution, because dividing by a number always gives us the same result as multiplying by its reciprocal. That's our rule for today. Division is the same as multiplying by the reciprocal. Now, sometimes we use another word for reciprocal. I probably ought to write that down, but it's going to be hard because it's tough to write with a mouse. This is called the multiplicative inverse. I'm just going to put mult, I-N-V-E-R-S-E. Sorry about that. I should have made that into a pop-up on your slide, an animation. But yeah, it's called the multiplicative inverse or the reciprocal. Let's look at another example. If I gave you 42 divided by 6, hopefully you have that memorized and you know that that's a 7. If I were to take the 6 and use its multiplicative inverse or its reciprocal, I would take this and rewrite the problem as 42 times the reciprocal, or times 1/6. Notice that 42 is 42 over 1. Multiply the numerators, multiply the denominators, and simplify, you come up with the same solution. That's going to happen because 6 and 1/6 are reciprocals or multiplicative inverses. Let's do one more. 50 divided by 10, hopefully you know that's a 5. The multiplicative inverse of a 10, hopefully you know that is 1/10. Dividing by 10 should give us the same answer as multiplying by the reciprocal or multiplicative inverse. Notice 50 is the same as 50 over 1. I multiply the numerators, I multiply the denominators, and I get 50 over 10, which is 5. That's because 10 over 1 and 1 over 10 are reciprocals. You multiply them together, you get 10 over 10, which is a 1. Now, the reason I'm mentioning this now is because it is often easier to solve a multiplication problem than a division problem. Now, in these examples, it probably is easier for you to do 18 divided by 2 than it is to go through this long process of 18 times a half. But if I were to take this and give you a problem like this, -1/8 divided by 3/5, rather than having to go through and memorize a whole new set of rules for division of fractions, instead we can just remember that division is the same as multiplying by the reciprocal. Division is the same as multiplying by the reciprocal. So if we can turn this into a multiplication problem, it's going to be much easier to solve. The reciprocal or multiplicative inverse of our number 3/5, we flip it over, it's 5/3. Notice that gives us 15 over 15, which is 1. I'm going to rewrite this problem as -1/8 times, the sign changes, the multiplicative inverse. Now, we should be able to use the same rules we used for multiplying rational numbers in the last lesson. That is, we simplify if possible. In other words, I'm going to look for things that are on top that will simplify with things that are on bottom. This doesn't happen to have anything. I'm going to multiply the numerators together, and then I'm going to multiply the denominators together. In this case, -1 times 5 gives me a numerator of -5. 8 times 3 gives me a denominator of 24. Notice I'm keeping my negative sign on top. Technically, you could put it in the bottom, but you're going to find long term that's going to be much more difficult to work with. And in our final answer, we always like to write it out front. Not too bad, right? If you're struggling with the multiplication portion of this, you really need to go back and watch that video first, because we're not going to spend a whole lot of time on this part of the lesson today. Instead, we're going to be focusing on what's happening up here, and then we're going to treat this a little bit like review. If you feel pretty confident, I would recommend that you try example 2 on your own by pausing the video and then restarting it when you finish. I'm going to assume you've gone ahead and done that. And I'm going to look at this and say, oh, well, the reciprocal or multiplicative inverse of 3/11 is 11/3. Notice 3/11 times 11/3 does in fact give you a 1. So I change my division into multiplication, use the revert or the inverse. I look for things that will simplify. Nothing in this one simplifies, so I just multiply the numerators and multiply the denominators. And of course, I like to write it with a negative sign out front. Again, if you're feeling pretty good, I would recommend pausing the video, trying this on your own. I'm going to keep going. Since it's a division problem, I'm going to take this second number and I'm going to find its reciprocal or its multiplicative inverse. In this case, it is -7/5. And you can see when I multiply those two together, it does give me a 1. I'm going to rewrite it as a multiplication problem using that reciprocal. Multiply the numerators, multiply the denominators, and we're done. Last thing I want to show you on this slide is division with mixed numbers. Again, it is probably going to be easier to do this as multiplication, but in order to find the multiplicative inverse and in order to multiply more easily, I'm going to strongly suggest that you turn these into improper fractions first. You're going to find that long-term improper fractions are easier to work with than mixed numbers, but when you're finished with the problem, your final answer should be a mixed number. So I know a lot of my students on the multiplication lesson chose not to do that, and they found that they were making a lot of mistakes as a result. So in order to make these improper, I would do 11 times -1, or I should say 11 times 1 plus the 8. Then I would stick the negative sign on at the end. Here I would do 3 times 12 plus the 5. And you're going to get 11 times 1 is 11 plus 8 is 19. Stick on your negative sign over the 11. Divided by 3 times 12 is 36. 36 plus 5 is 41. This is going to be 41 over 12. Once I've got it written as an improper fraction, then I'm going to look for the multiplicative inverse. In this case, the multiplicative inverse of 41 over 12 is going to be 41 over 12 times, I flip that over. Notice I didn't even bother to calculate what that is because it doesn't matter. 41 times 12 and 12 times 41, the commutative property says those are the same. It's going to be something over itself, which equals 1. Didn't even have to bother figuring that out. Once I know that, I'm going to rewrite this division problem as a multiplication problem, and then I'm going to use that inverse here. I'm going to look for things that will simplify. In this case, nothing does. Multiply straight across the top, straight across the bottom, and I give my answer. All in all, I don't think this should be too bad. I can point out to you a couple common errors. First common error is some people get in the habit of just flipping everything. So like on example 1, they might accidentally flip the negative 1/8. Remember, don't flip the first number. All you do is change it to multiplication and flip the second number. I know a lot of my students refer to a quote their elementary teacher told them, which was a keep, change, flip. If that helps you remember how to do this, certainly you're welcome to do that. Also, don't forget to keep track of those negative signs. A lot of students tend to get carried away with the multiplication part of it and lose track of those. Always double check to make sure your answer should be positive or negative. And then lastly, sometimes people forget to make these into improper fractions first. I'm going to highly recommend you take the time to do that. Got one more slide with 4 more examples for you. I just want to run through these pretty quickly. If I have negative 8/7 divided by negative 16 over 21, we're going to do the same thing. We're going to look for the multiplicative inverse. In this case, I change the division to multiplication. And then I take the 16 over 21 and I flip it over. Now, remember, we're always looking for ways to simplify. In this problem, I happen to notice that 8 and 16 would be the fraction 8/16. 8/16 is the same as 1/2. Don't lose track of your negative sign. Negative 21 over 7 would be negative 3 over 1. And then we just multiply those together. The reason I put these on here is, first of all, to remind you to simplify before you multiply together, and also to remind you that this cross simplification that we're doing is a multiplication rule, meaning I can't cross simplify up here even if the numbers look like they would simplify. You must flip before you simplify. You might even take the time, if you're taking notes, to write that down over here on the side. Flip the side, or change it to multiplication before you simplify. And of course, you want to make your answer a mixed number. If you're feeling pretty confident, I would recommend pausing the video and trying this on your own. I'm going to go ahead and continue working, assuming you have done that already. I'm going to change this into a multiplication problem. Division becomes multiplication. I use the reciprocal of that second number. I then look for ways to simplify. 12 and 27. Both of those are divisible by 3. So 12/27 would simplify to 4/9. Don't forget your negative sign. The 20 and the 25 would simplify to 4/5. There is no negative sign. Multiply your numerators, multiply your denominators, and you get negative 16 over 45. And of course, I like to put my negative sign out front when I am finished. Again, I'd recommend at some point you pause these, try them on your own. I'm going to keep going, assuming you've already done that. Notice that I have a mixed number here. I want to deal with that mixed number first. I also have a whole number here, so I want to write that whole number as a fraction. 6 times 5 is 30, plus 5 is 35. Stick on our negative sign. Negative 35/6. And then don't forget that negative 28 is the same as negative 28 over 1. See your division sign, so we're going to turn this into multiplication. I multiply by the reciprocal of negative 28 over 1. That's negative 1 over 28. I look for ways to simplify. 35 and 28 are both divisible by 7. So the fraction 35/28 would become 5 and 4. Don't forget your negative sign. Notice, of course, that the negative 1 and the 6 do not simplify. I multiply straight across, and there's my solution. Last one, again, mixed numbers. Make sure you make them improper first. This is 2 times 9 is 18, plus 7 is 25/9. divided by 5 times 1 is 5 plus 4. That's 9/5. Don't forget your negative sign. Once you've done that, let's change it to multiplication. So division becomes multiplication, and we use the reciprocal or multiplicative inverse of negative 9/5. Notice here that if I try to cross simplify, 25 does not simplify with 9. Negative 5 also does not simplify with 9. And you get negative 125 over 81, but we always put our final answer as a mixed number. One thing I want to caution you about, notice up here, it looks like the 25 and the 5 would simplify. It also looks like the negative 9 and the 9 would simplify, but cross-simplification is a multiplication rule. You cannot cross-simplify with division, doesn't work. Hopefully this has been useful to you. As I mentioned before, there are other ways to teach division, but I find that just using that, using the rule about division being the same as multiplying by the reciprocal or the multiplicative inverse tends to be a lot less confusing for most people. So, as always, I do appreciate you taking time to join us here today. Make sure you smash that like button, make sure you ring that bell to turn on your notifications, and of course, please leave us a comment in the comments section. I have been informed that there have been a couple typos on the last couple slides, or a couple of slideshows, so I'm going to continue to work on that, but please feel free to point those out to me. You're helping me do a better job as well, and I want to make sure I don't confuse any of you. Take care of yourselves. Thank you so much again. Bye-bye.